Now, if we wish to reverse a string in C for some reason, how can we achieve this result? And for those that have been programming in Python, you know that one of the characteristics of Python that makes it very interesting is it has a rich library of functions that can do certain work for us, and we don't need to actually write out functions by ourselves. Now, an example is, in this case, we have a reversed function that can actually, okay, I'll just switch to my Python file. For Python, we have a reverse function that can actually do this magic for us. Okay, so what the reverse function does, I'm going to write my string, say str is equal to watermelon. Now, I'm not doing this in Python to make the Python guys happy, but I'm actually doing it so that new programmers or people that are new to coding in general would have an insight on the differences between a higher level language like Python and a much lower level language like C. Now, when we get to C, I will show you the advantage C has over Python as well. So Python will do things much faster for us anyway. So what do we do? Okay, I'm just going to create another variable where I'm going to store my reverse string. The string is watermelon. So reverse underscore str. This is going to store my reverse string. So now, what I'm going to do here is, because what reverse does, it returns a sequence or a list of the reverse characters one after the other. So I'm going to create a list here using square brackets. I'm going to write str there. So then I'll use my for loop. So I have n for n in. I use this for loop to iterate over every element in that sequence that reversed function return. So once I do this, I can print out reverse string, save my code, and I run this code, and we get a list of characters one after the other from the last character to the first character, that is N to W. So just to make this, to remove the square bracket and the quotes, the comma, to make it one word, just like it was originally watermelon, something like this. You can use our join statement. So one thing I like about the join statement is you can use it to actually join set of characters like this and make them one word. So you can either join them with any separator of your choice, but in this case, I'll just leave my quotes empty to indicate that I don't really want any particular separator. I just want to use my joins. I just want to join them like that, something like this. So I put this, I've called my join, I close my parentheses here, and this should work. So when I save my code, I run this code, yes, I get every character here, but no more square bracket, no more quotes, and no more comma. So that is the beauty of the join statement. So now there's another way we can even do this in Python, which is actually even faster than this, and that is using our sliding syntax. We have a lot of sliding syntax, and sliding syntax just give us many ways to will I say manipulate our string or our list. It gives us ways to get our strings in different forms or different ways. In this case, if I want to write out this string, which is actually a list of characters from the ending to the start, all I need to do is to call string, and I use this as my index, colon, colon, and -1. So what -1 implies is start listing my list items from the last element, which is n, and stop when you get to the 0th index. So basically what I could have done is I could have written 0 here, I could have written 0 here, and I could have written 0 here as well. But the fact that I did not indicate 0, 0 simply means that automatically it will assume that it's 0, 0. That's from the ending to the beginning, something like. So I could have put intervals if I want, or kind of boundaries. So what this does, save my code, I run it again, and as you can see, we get the same value. So this is Python for you. So but when we come to C, okay, We are in C here. Let me just clean this. Okay, C actually doesn't have a particular function that can do this for us, but still, C gives us the power to control what's on the memory, kind of using the idea of pointers. And pointers is very interesting because it gives us low-level memory management ability. Most languages, especially higher-level languages like Python, which we just coded with, don't have this ability to access the power of pointers. Other languages like JavaScript, the same thing. They don't have the power to access the power of pointers. So they're not this close to memory compared to C. So many of these higher-level languages are built upon C, and C is actually a widely used language today. So there is STD. When I made some research, I realized that there's a function in some, I would say in some compilers. Some compilers are compatible with this function, strrev. That's supposed to be, I think, string reverse function in C. But this function is not a standard ISO function like starlen and starcompare that we're going to be using in this video. This function is not a standard. So some libraries may work with this function, some older libraries, because it's an outdated function, I think, but some libraries may not work with it. So if I told you how to try it, perhaps it works with your compiler, doesn't mean that you should be using it because of lack of portability. So it's something that might work with you, but it might not work for other people when they share your code on GitHub or something like that. So what we are going to do in this video, we are going to create our own function that can do this reversing for us. The first thing I'm going to do, I'm going to include some preprocessor headers. The first one, of course, is my input and output. Then I'm also going to include, I'm also going to include string.h. All right, so int main void, where I'm going to write in my code. Okay, so unlike Python where we just declared our string without any data type, the only thing we did in Python to indicate or to tell Python that watermelon is actually a string is putting the single quotes. In C is a completely different story. You actually have to start every declaration with a data type. So this is the first approach. I'm going to create a pointer that will point to a string in memory, and I'm going to call a function which I'm going to write, a reverse string function which I'm going to write. And in that function, we are going to create an array that will have empty slots, and I'm going to fill in that array with members of the original string which we are going to declare here. So that is the first approach. And I'm going to see how we can use star copy to actually copy every element in our new string. That's the one we created inside, declared inside our array in the function. We're going to see how we can copy them into this old string, which I'm declaring here now. So how do we declare pointers? We just say char star. So we have something like this, watermelon. So now what I've done here is I've created a pointer called str. This symbol, this asterisk symbol here, is how we declare pointers. We are saying that str is a pointer that is pointing to a memory location somewhere in memory. I'm not going to specify where yet because actually I don't know where particularly it's created. So and it's actually pointed. Remember always that when you are dealing with string, a string on its own is a list of characters. So basically this pointer is pointing to the first element in the list, which is the first character in the list, which is W in this case. So once we have this, I would call my reverse string. Remember, this is what I said I want to write. So this is it, and I would pass an argument of string inside. So what I'm doing is I'm actually giving it the address that this pointer is pointing to. Remember, a pointer is actually just is a unique variable. It's a unique variable that stores the address of another variable. In this case, we are storing the address of W. It's more like if you go to that pointer, what you're going to see there is the location of W. So I'm passing the argument, that address, as our argument for the reverse string function that we're going to call here. So, and when I've done that, I'm just going to return 0, and I'm done. Okay, so I'm going to come down here and create my reverse string function. So reverse string, and it's taking a pointer as well. It's taking a pointer as well. So the reason why it's taking a pointer, why do you think it's taking a pointer? Of course, it's taking a pointer because the argument that is coming in must rhyme with what is actually receiving that argument, with the parameter that is receiving that argument. This char star st arrow here, okay, I'll just use, I like using different variables or different names for my parameter against my argument. So, but that doesn't mean that it makes any difference. str is coming in, and it will be and string would store that address. So that is why in particular we are using a pointer to receive it. Why? Because a pointer holds addresses. So for instance, if you say you want to use this, for instance, just char string. So this is not a pointer, by the way. This is actually just a single character with the character data type and the name of the character, the name we're using to store the character. So you see why this cannot work, because an address is coming actually. str is an address, and we are storing it inside a character, so it will not work. So this would work. So I'm not going to return anything. This function will not return anything. So we're going to have void here. In the case whereby it was returning, of course, we're going to have the data type of what is returning, either if it's a normal variable or if it's a pointer as well. Okay, so what am I going to do? Remember I said that I'm going to create an array. This is the first method. We're going to create an array that and inside the array we're going to store all the members of the original string that str was pointed to from the ending to the start. But before that, I'm going to call my style length function, say, because I need a for loop, and I need a certain number that I'm going to use for my boundaries of my for loop. So I'll say int len is equal to style length of what? Style length of string. Style length of string. Okay, remember this is string. So basically style length is a function that it takes in a string. In this case, it's going to be taking in watermelon, because that's what string is pointing to, and it's going to count every individual characters in that string. So it will start from the first character W, A, and it will count up to N. It will stop when it sees a null terminator, because every string is ended by a null character, which is actually \0. So it will stop when it says \0. So which means what style length will return is a number. That was why I stored it inside int, and it will store it inside the length variable. So it will return a number that is the length of that particular string. Okay, I hope we are still getting it so far. So int length is equal to style length string, and I'm going to create my character array now. So I'll say this reversed char reversed, and I put something like this. Now I'm going to have to put a number inside this square brackets to indicate that this is how wide my array is. So that was why I called len first of all, because I want to know how wide my array should be, how many slots it should have, because I cannot just put 100 there. If I put like 100 there, it's going to work of course, but I'm going to be wasting space, because I know that watermelon is not having 100 characters. So what do I need actually? Should I put len, or should I put len plus 1? What do you think? Len or len plus 1? So it's len plus 1. Reason being that I said at the end of every string, every set of characters that make up a string, there's always a null terminator, which is also taking 1 slot. So if the length of the string, of course, is 10. That's if you count all the characters in watermelon. You have to have a last slot for the null terminator. So basically, we need 11, not 10. So this is what our array will look like. We've declared our array now, but there's nothing inside that array. There's nothing inside this character array. So we are going to put something inside, one after the other. For the first, the one thing with arrays, array gives us ability to index into, like say, reversed 0, reversed 1. So we're going to be indexing into each and every one of those slots from the first one to the last one. And the way we are going to iterate through all those indices is using a for loop. So I'm going to say for int I equals 0, I is less than len, I plus plus. So what I'm going to do here, so we're going to start from the first character in reverse. So say reversed 0. Now it won't be 0 in essence, but okay, I'm just trying to use 0 so that it will make you easily understand what we are doing. So reversed 0 is actually going to be equal to, now this is the tricky part. So we have as our argument here a string pointer, or a pointer called string that is pointing to the characters watermelon, that's WA and all that. So but the fact is, one particular pointer notation that is interesting is there's a way we declare pointers which is like this. Say char star and the name of the pointer. But apart from that, we can dereference into a pointer. Now, dereferencing into a pointer is when we want to go inside our address that is pointing at and actually get the values that is stored inside that particular address. So in this case, the address is, I don't know where the address is, but it's like a certain location. But how can we go inside our address now and get what is inside here? We use this. We use star before everything that we want to write. So for instance, if I say star string plus 0, for instance, is referring to W. So that is a beautiful part. Star string plus 0 is referring to W. Star string plus 1 is referring to A. That is remember the first index is always 0, the second index is 1, and like that. It means even though this watermelon has 10 letters, the last index is going to be slot 9, and the first index instead of 1 is going to be slot 0. So you get the idea. So the first index is going to be 0 here, let's just say, because we are referring to the first character in our array, that's reverse 0. So this is star string plus 0. So basically, how do we write this? Remember that we are dealing with I here. So I'm going to say this is I, and this is also going to be, now take note of something. The first character in our reverse array here is going to be the last character here in our original string array. Let's put it that way. On our original string list, kind of character list that makes up the string. So how do we describe the last one here? Remember I said that if the first one is 0, let me just write it again. If the first one is 0, the last one has to be 9 in this case. So but how do we write 9? Of course, we can't use 9, we have to use length. We say length minus I, but length is actually 10. So say length minus 1 minus I. So this is I as well. So just for clarity, I'm going to explain it one more time. When I is 0 when the for loop runs for the first time, when I is 0, len is 10, and of course, remember I said len minus 1 here because 10 minus 1 is 9, and we actually need the last index is actually 9 and not 10. So that was why we said len minus 1 here. And when you subtract I from it, you get 9 minus 0, which is still 9. So this works. So once we do this, we're actually done. But the next thing we have to do is to add our null character and say reversed len, which in this case is going to be the 10th character is going to be our backslash 0, and say reverse len is equal to backslash 0. So when you are defining characters, you use single quotes as I did here instead of double quotes. So I close with my semicolon as well. So we are done with this, and after reversing our string here, after calling reverse string, which we've successfully written here, we just have to print out the string. We print out str. So we use the format specifier %s and we print out str, and let's see what we have now. Okay, so but before that, to avoid getting any errors, we have to carry this function, so-called function prototype, to the top. So we have something like this. Exactly. So this is to tell int main, because if we do not carry this function prototype to the above the main function here, our main function, it won't know where to find the reverse string function when it's calling it here. So this is how we do this. So we save this code and we run. So when we run, we get watermelon. We get the same thing that we have here. So what does this imply? It means that there's no reversing so far. So the question is why? Why is there no reversing so far? Now, is there a problem with our function? So let me do something. I want to just comment this out. Comment this out means that I don't want this part to be part of our code for now. And instead, let us print the character here inside the function. So I'll say printf reversed. So of course, my format specifier %s, I'm going to print out reversed. Okay, so if we do this, let us see whether what we are going to get here will be the reverse version, to see if there's actually a problem with our function or not. So you can see that when I printed out the reverse inside the function here, we get it actually reversed. So what is the problem? What is the problem? That's the question. Now, taking of something, we can say, okay, since this function is correct, perhaps we've not done the final step, which is to copy everything inside our reversed array here into the original array that we had here, into the original string. So we can say, okay, let's use star copy to do the copying. So say star copy, and what star copy does? Star copy takes two arguments: the location which we want to copy into and the location which we want to copy from. So where we want to copy into is, we want to copy into string, and we are copying from where? We are copying from the reversed array. Copying from the reversed array. So if we do this, we save our code and we run it. Let's see if we actually get the reverse version printed out. Save my code and we run it. So when we run it, what do we have? Let's see. We don't get anything. So this is an undefined behavior. This is an undefined behavior. I've done something intentionally here, and the reason why I did that is because I wanted to understand that when we originally declared our pointer here, our pointer that was pointing to the string, in fact, this string is called a string literal. The way we declared it is called a string literal. We could have, if we didn't want to have a string literal, we could have pointed to a certain memory and gradually added characters into that memory location. But when you just declare a pointer here and points to a string, and you just write the string here the exact way we did this, what we actually declared here, this string is called a string literal. So string literals in particular cannot be modified because they are stored in what we call a read-only memory in our memory, in our computer's memory, stored in a read-only memory. Now, there are actually different memory segments in our computer's memory. We have like I've mentioned, the read-only memory, we have the stack, we have the heap. So particularly this, when we declare this line of code, when we wrote this line of code, the pointer itself was stored on the stack, but this string which it was pointing to was stored in another memory location called read-only memory. And what that means is you cannot modify this string. So that is why when I was calling stack copy here, stack copy was trying to do some modification on the string. It was trying to copy everything that was in reverse, which actually was correct by the way, into string. But we have an undefined behavior here. The program crashed. That's why you didn't get any output here. And if we keep running this, we won't get any output because we are trying to modify a string literal, which is supposed to be in a read-only memory location. So there are various things in C that can actually make our program crash. One of them is when, like in this case, we are trying to modify a string literal. In some other case, you can have a buffer overflow, or that will lead to a seg fault or segmentation fault. So that will happen if you declare an array. For instance, you can see in this case here we declared reversed length plus 1, which we know it's 11 because watermelon is 10 characters plus 1, which is 11. Imagine we are trying to access reversed, we're trying to access the 50th index of reverse, and we know that reverse is actually only up to 11. In that case, we're also going to have an undefined behavior, which will lead to a segmentation fault. Most times the compiler will just write segmentation fault here in the terminal for you to see that this is a seg fault. Another thing is, if you're trying to dereference into null pointers, that's a pointer that is pointing into nothing, basically. You're trying to dereference into it. Remember, I use the word dereferencing here. You're trying to go into it and do some changes. You're going to also have an undefined behavior, so you should be very careful. So what can we do now? It means that what I need to do is I shouldn't declare a string literal. Rather, I can declare an array. I can actually declare an array. I'm trying to correct the mistake we made here. I can actually declare an array like this, and the array would have watermelon. Okay, so but the difference is I'm not going to have this side anymore. I'm not going to have this side anymore. Rather, I'm not going to have this side anymore as well. So there are a few changes we are making here. Remember, initially we were using a pointer to actually receive the memory address that was coming from the pointer here. So, but in this case, since we are having an array, so we should also be receiving with an array. So I'm going to have something like this, char string, then I'll just put my square bracket to indicate that what's coming is an array. That's str, that is the argument coming into this parameter is an array. So this is what we have. Then I would think I should make the changes here as well so that I won't be getting any funny errors. Okay, so this is what we have. All right, so so the only difference now is what we have inside our for loop. So I believe we should be having something like a string, and the first character of our reversed array should be pointing to the last character of our string array that was coming. So that's len, which is 10, len minus 1, which is 9, len minus 1, which is 9, minus I, which is 0 in the first iteration, or when it runs for the first time. So then I would still put this part is still okay, but yes, then now we can copy everything in reverse into string. So stack copy will work now. Stack copy will work now, and we can print our string. So I'll save this code and I'll run the code, and we can see that we have our reverse string now. Okay, so I hope we're clear with the mistakes we made before and why you should not try to modify a string literal. So, and there's another way we can do this briefly before I close this video. There's another way we can actually do this. Instead of using stack copy and instead of using arrays, I don't want to do this. I don't want to create a new array. I actually just want to modify the original array, or in this case, I still want to work with pointers, So I have this, but I'm not going to do this again. I'm not going to declare a string literal like I did before. In place of that, to avoid declaring a string literal like that, I said in that case there's a read-only memory location which you shouldn't touch. I'm going to use malloc. Now what malloc does is I'm dynamically allocating memory, and what that means is I can actually modify. The memory comes from the heap, and the good part is I can modify it because that is what I want. I don't want to have an undefined behavior like before. So I'm going to malloc, and I will give it a size of 11 times the size. This is how you declare it. Say 11 times size of char. So I have something like this. So what this implies now is I'm pointing to a certain space in memory, and that space has 11 slots, 10 for watermelon, and the last slot for the \0, which is the null terminator. So I'm going to ask the user, remember I'm just trying to fill in that space. I'm going to ask the user to enter, just for formality, say enter a word, but I know that the word in this case is watermelon. So I'm going to tell him to enter a word, and I'm going to use scanf to actually store that word inside, to pick this word individually and store it inside this malloc space. So I'm also using this as a format specifier and str. Okay, so when I run this code, the first thing is to ask me to enter a word, then it will store that word inside this space. Then we'll call our reversed string function, and we'll have printf to print it out, and hopefully it should be reversed. So the next thing is this. Okay, I think we still need this. We still need len, but since we are receiving a pointer, I'll remove this, and just like before, we have this, and just like before, I'll remove this, and just like before, we had this. Okay, so what do we do here now? The reason why I'm trying to do this is because I'm trying to help you understand that when we work with pointers like this, I don't know, when we call the function and we are giving it the argument str, and we are receiving it with a pointer parameter here as well. The truth of the matter is we are passing by reference. So passing by reference is different from passing by value. There's another video I've done on explaining the differences. So, but I want to use this video to explain it. So, we're passing by reference here means that we're actually passing the address and not the original value. We did it the first time, but the mistake we made is we were actually trying to modify a string literal. But I want to do it the correct way now, using pointers alone. So, we should have our for loop, but in this case, I'm going to say that for int I is equal to 0 as usual. I is less than len. I is less than len I plus plus. But what do we have here now? Okay, so what I'm going to do now is, instead of saying len, I want to do some modification. Instead of saying len now, I'm going to say len divided by 2. So in this case, my len is going to be 10, of course we know, because I'm going to enter the word watermelon. So 10 divided by 2 would be 5. 10 divided by 2 would be 5. So just play along. I'm going to explain in a bit. So okay, let me just do this. So the first thing I'm going to do is I'm going to declare a temporary variable that will store the value at string I. The value at string I. Remember, in the first iteration, I is going to be 0. So in this case, let's just say the value at string 0, which is the first index or the first location, which is actually W. Then I'm going to take my string. I'll say that string I. Now I want my string I to change. Remember, I've stored it in a temporary variable, but now I want it to change. It's going to change into the last one. It's going to change into the last one. And what is the last one? Len minus 1 minus I. I'm sure we're not too confused about this anymore. We're subtracting 1 because I explained that the last index is always 1 less than the number, that is 9. And I will be 0. When the first iteration, when I is 0, it makes no change. So first is equal to last. String 0 is equal to string 9. This is what this basically means. So if I change 0, the first one to the last one, I should change the last one to the first one immediately. So string, the last one of course is this string len minus 1 minus I. This is the last one. So I will just change it to the first one. So remember, the first one is no longer string I. It's because we've changed string I to the last one. But you can see why we brought about temporary variable to actually store the first one. So I will just say is equal to temp. So whatever temp is. So in the first iteration, you can see that temp will store the first character in that string, which is W. Temp will store W, and we change W to the last character, which is N, and we come to the next line and we change N to W, and we move to the second one. The second iteration, I will become 1, and we say int temp is equal to string I. That's string 1, means that we are referring to the second character, which is A. That's after W we have A, so temp will store A. Then we say string I, which is the second character. We'll change it to the second to the last. This will be second to the last now, because 9 ln minus 1 is 9. 9 minus 1 is 8. So that's the second to the last. So we change the second character to the second to the last character. And now we change the second to the last character to the temporary, to temp, which is storing A. So that is what we're going to keep doing until we get to the fourth. Until we get to the fourth, which is I less than 5 here. So we keep doing it until we get to the fourth index. And the fourth index is actually the 5th character. So this should work. This should work. So if we do it this way, you can see that any change we are making here is actually going to reflect in our string, in where string is pointed to immediately. It's going to reflect inside our malloc space immediately, because we are passing by reference. So I'm just actually doing this to give us the same answer we got before. It's an alternative way which you've learned, but most importantly, you've seen another application of pass by reference. So following my other video, if you want to understand more of pass by reference, you can watch. I would link the other video in the description of this video. So if we do this, okay, I think that's all. That's all we need to do, and our code should work. So I'll save this and I would print this out. Okay, we have incompatible implicit declaration of malloc. So the issue is malloc is not inside any of these libraries, so we actually need to include where malloc is, and that is stdlib.h, stdlibrary.h, that's standard library.h. So I'll save this, I'll run my code again. I see, okay, enter a word. Let me clear this and run again. If I clear this and I run again, I get enter a word. So I'm going to put watermelon because I only set memory that could hold something like watermelon, and that's what we get. So thank you guys for watching. If you like this video and you've learned something, please you can subscribe to my channel, comment, share this video so that I can be motivated to keep making videos like this. Thank you.